Hello guys, welcome back to Maison African Motives, still on mathematics grade 10 revisions. So in this platform, we have got the question paper, which I actually took from the department, which is November 2018. That's November 2018, paper 1, grade 10 mathematics. So we shall try by all means to work out the questions that we have so that we can manage to work everything that we have. So without wasting much time, guys, all you need is to make sure that you read your instructions, all right? If you are answering any question paper, okay, make sure that you read the instructions. So here, the most important part that we are going to focus on is on the degree of accuracy that you're going to use. If necessary, round off to 2 decimal places unless stated otherwise, that they might tell you what to do, like the decimal places to use. So you just have to work with that. But if you are not told, then to 2 decimal places. All right, so without wasting much time, guys, we're going to rush through the questions that we have. On number 1, we are given to factorize the following expressions fully. So I think I managed to show you the marks. So I'm just going to at least increase so that we can all see what is happening here. So we're given to factorize the following expressions fully. So in this case, I can just manage to utilize the space that I'm having because this is a simple expression. So I can even use this part here. So we are given 4x minus x to the exponent of 3, factorize fully. So what you need actually is to look into the expression and see if there are common factors from what you're given. Do we have any common factors? So in this case, we can cross-check. You've got x and x to the exponent of 3 or x cubed. So that means you can factor out that x, which is the highest common factor. So whatever that you must factor is the highest common factor, which is x. So you're going to have 4 minus, here you've got 4x and x, that definitely will cancel, guys. This is 4x over x like this. So that will cancel. Then you remain with 4. The same thing with x to the exponent of 3 and x. If you divide, this will give you x squared. That is x to the exponent of 2. From this concept, we can cancel. There are 3 of them. So if I cancel here, I'm going to remain with 2, or you can subtract minus 1. Since you are dividing the same basis, you're going to obtain x to the exponent of 2. From the expression that we have here, we can see that we are not yet done. Remember, we are supposed to factorize fully. So we are supposed to cross-check again and see if we are having any common terms. In terms of common terms, we do not have, but this part, it is one of the most important terms from your difference of 2 squares. If you can write your numbers in the form of a squared minus b squared, this is the same as a plus b into a minus b. So what does it mean? It means we can write this 4 as 2 to the exponent of 2. That is 2 to the exponent of 2. So the moment I can write this in this format, that means I'm going to have 2 brackets, just like a plus b, but here I'm going to focus with 2 and x. So it is going to be 2 plus x in one bracket, another bracket, it will be 2 minus x. That's the difference of 2 squared. Or you can simply use the square root concept, the square root of 4, that is 2, the square root of x squared, that is x. So one bracket is going to add the square root, another bracket is going to subtract the square root, but don't forget the x that is outside of the bracket. So it's another way that you can simply use. All right, the 1.12, let me just remove this part so that we can cross-check the 1.12. We are given again to factorize. This is x squared plus 15x minus 54. So if you are given this type of an expression, it's a quadratic expression. As you can see, the highest exponent that we have is 2. So we're dealing with a quadratic expression. So whenever you're dealing with a quadratic expression, check if the coefficient of x squared is 1, like in this case, simply you're going to have 2 brackets that we are going to use for x and x. So the x and x is representing the factors of x squared. Then what you're going to do is to focus with the constant term, which is the negative 54. Focusing on negative 54, what actually do we need here? We need the factors of negative 54 that when we add them, they must give us the middle number, which is the 15. So we are supposed to test our numbers, factors of negative 54. So I want you to try these two numbers, 18 and negative 3. Actually, there are so many numbers that we can multiply to give negative 54. I want you to see something like we can have negative 27 by 2. If we multiply these two numbers, we get negative 54. But the concept now is when you add the numbers, if you add negative 27 to 2, are you going to obtain this number? We are not obtaining the number that we are given, but looking into 18 and -3, let's add these two numbers and see. So 18 plus -3, that is 15, which is the number that we have here in the middle term, which is 15. So these are the two numbers that you're going to work with. Okay, that is, sorry. So we are going to have these two numbers, which is plus 18 and -3. So that is the concept that you are simply working with. All right, so I think we're done there. Let's check the other part, which is the 1.13. We can even try to work it here. So if you are given this type of an expression, this is the factorization that you can apply by grouping the terms. By grouping the terms, you have to cross-check first. If you have got terms which are common for the first two terms, this is an expression with 4 terms. If you can count 1, 2, 3, 4. So what you do is that you group them into 2. For the first 2 terms, we have a common term. Yes, y is common. So that means you can factor out y in this case. If we factor out y here, in place of y, you're going to remain with 1. That's y divided by y. That's a 1. Minus xy and y. If you divide y and y, you remain with x. So what you're supposed to do is that you are supposed to factor out a common term between x minus 1. This is a plus x and minus 1. But whatever that you're going to have, you must have the same bracket as the first one that we have of 1 minus x. So this is x minus 1. As we can see, our x here is negative, 1 is positive. In this case, x is positive, 1 is negative. So what are we going to do? We are going to simply factor out a negative so that our x is going to be negative, just like the first bracket. And our 1 here, if we divide -1 and -1, it is going to be a positive. So this is actually -1. So that means 1 minus x and minus x plus 1, these two terms are the same. It's just like writing -1 plus 2 and 2 minus 1. It's one and the same. So you can write this in this way so that you can actually understand what you're writing. So this is the same as 1 minus x. All right. So if the two brackets are common, remember what you are supposed to have is to factor out the common bracket of 1 minus x. Then what do we remain with? If we factor out this bracket here of 1 minus x, you remain with y. So you're going to have y here. And on this part, if you factor out 1 minus x, you're going to remain with -1. So that is the answer that you're going to have. So you can even find this answer in this form, starting with y minus 1, then 1 minus x, still one and the same thing. We are having the same expression, just like 2 times 3, 3 times 2, one and the same thing. All right, so that was 1.13. I think everything is clear. So I'm going to remove this part so that we can cross-check the other part that we have on 1.2. So 1.2, we are given to simplify the following expressions fully. That is, you're supposed to check what is happening to the expression. So the first part, if we are to cross-check on 1.21, that is an expansion of brackets. We are supposed to expand the given brackets. So you are supposed to multiply this second bracket by whatever that you have in the first bracket. So you're going to start with x. So x is going to multiply with x squared here. That is going to be x to the exponent of 3. Then x and minus x, which is going to be -x squared. Then we've got x here and 3, which is going to be positive 3x. You're done with x. So x is to multiply each and every term. Okay, if you are done with x, then you move on to +2. So +2 is supposed to act the same way, supposed to multiply x squared, -x, and also 3. So if you multiply 2 and x squared, that is positive 2x squared. 2 and -x, which is -2x. Then we've got 2 and 3, which is 6. So from there, you're supposed to collect like terms. You can use your calculator to add the numbers, or you can just add commonly if you know the numbers. All right, so you've got x squared here and also x squared here. This is same as -1x squared, and this is positive 2. So you can even add from your calculator, that's -1 plus 2, which is actually 1. So that is 1x squared, but we can't write it 1x squared. We just write it as x squared. All right. We are done with x squared. We move on to x. We've got x here. So you're going to take out the 3x and the -2x. So 3 minus 2, that is a positive x. So we've got a positive x here, which is positive 1x. All right, then we move on to 6. It's just a constant. So we just have to add 6 that we have. So you're done. We do not have anything that is common. that we can factor out, just leave it like that. All right, on 1.22, we are asked to simplify. So we're supposed to check the question or the layout of the question that you're given. So let me just remove this part. All right, we are given a fraction that is on 1.22. We have got 5 over x plus 3 minus 3 over 2 minus x. All right. Given fractions like this, for you to subtract, whether you're adding or subtracting, you're supposed to find the LCM of the given denominators. We've got x plus 3 here, we've got 2 minus x. So what you're supposed to find is the LCM. Some they can refer this as the LCD, the lowest common denominator. That is the lowest common multiple. So in this case, if you are given expressions, what you're supposed to check, are they the same or not? If they are not the same, then you just have to take all those terms that you have. Remember, the LCM is a multiple, so you're supposed to take all the terms that we are given. In this case, we are working with x plus 3 and 2 minus x. These are the two brackets that we have. So you're supposed to divide now the LCD or the LCM, you divide it to the first, which that is x plus 3. So if you divide these two, definitely x plus 3 and x plus 3 cancel out, but do not cancel out. Just know that this will cancel, so you remain with 5 into 2 minus x. You are remaining with 2 minus x here. Negative 3 multiplied by whatever that you are going to give. So if you divide 2 minus x here, 2 minus x, as you can see, 2 minus x and 2 minus x will cancel. You remain with x plus 3. So this will be x plus 3. So that is the concept that you have. So from there, you can expand the brackets. The first bracket, you're multiplying by the 5. The number that is outside the bracket is going to multiply every term. So it's 5 times 2, that is 10. 5 times negative x, which is negative 5x. We move on to negative 3. So take note the number has to affect with the sign. So that is negative 3. So it's negative 3 times x, which is negative 3x. Negative 3 times negative 3, that is a negative 9. All right, so we don't forget the LCM, that is your LCD. Don't forget to write everything there. So we've got x plus 3 into 2 minus x. All right. So from there, we can collect like terms. In this case, let me just use this space here. So you can just collect the terms that is constants together. We've got 10 and negative 9. So if we subtract 10 minus 9, that is 1. All right. So we've got 1 here. Then we've got x and x here, which is negative 5x and negative 3x. That is negative 5, negative 3, which is negative 8x. Everything over x plus 3 into 2 minus x. So that is what you're going to have. But from this expression, someone could actually want to write this in another way, or to write this in another way. Let's say we've got 5 over x plus 3 like this, minus 3 over 2 minus x. We can, someone can say, what if I factor out a negative? Since this second expression, the x that we are having here, which is the constant, our variable that we have, sorry. So from this variable that we have, we can see that it's having a negative. So we want to avoid that negative. So what are we going to do? We can actually factor out a negative from this expression. So by factoring out a negative, you're going to find an expression such as 5 over x plus 3 minus 3 over. So let's say we have factored out a negative. That means the x is going to be positive. Then if we factor out a negative on 2, remember 2 is a positive. So by factoring out a negative here, it is going to be a negative. So that will be negative 2. So this negative that we have and this negative will affect each other. That means it's now a positive. So it can be 5 over x plus 3 plus now 3 over x minus 2. So it's just writing the x being positive, just like the first part. Someone can want to, someone might will need to write in that format. It's still one and the same thing, but the answers, they are going to just look a little bit different. As you can see, we are now having x minus 2. There we had 2 minus x. But the same scenario, like what we did, is the one that you're going to use, which means you're going to find the LCM of the everything here. So this is going to be x plus 3 into x minus 2. So you divide just like the previous part. So here we are going to have 5 multiplied to the answer that you're going to divide. If you divide LCM divide by x plus 3, and x plus 3 will cancel, which means you remain with x minus 2 plus, if you divide here, the LCM and x minus 2 and x minus 2 will cancel, which means you remain with x plus 3. So this will be x plus 3. So expand brackets, just like what we had here with expand the given brackets. So this is going to be 5 multiplied to x, which is going to be 5x. 5 and negative 2, that is negative 10. 3 by x, which is 3x. Then 3 times 3, which is 9. Everything over x plus 3 into x minus 2. All right, so you just collect like terms. It's like the previous part, guys. We can collect like terms here. We've got 5x and positive 3x. So we're adding 5 plus 3, that is 8x. Then we move on to the numbers. We've got negative 10 plus 9, which is negative 1, or you can just use a calculator here. Negative 10 plus 9, that is negative 1. So this is going to be negative 1. Everything over x plus 3 into x minus 2. All right, so this is what you're going to have at the end. So as you can see, the answers, they're a little bit different, but it's the same expression. This expression that we see here and this expression here are the same. So that is actually what we had. So it simply needs you guys to work out with more questions. Yeah, more question papers that can actually help. So that was actually 3 marks. All right, so let's check 1.23, where we are asked again to simplify the following expression. So we have got exponents there that we are given. So let's see, from this space, we can just utilize this space here. So that's 1.23, where we are given 25 to the exponent of minus x multiplied to 15 to the exponent of x plus 1, everything over 3 to the exponent of x by 5 to the exponent of negative x. If you are given such type of an expression, what you're supposed to do is to at least write the given numbers in the same way, like we've got 3 and 5 in simplest form. That is the simplest form that we have. So let's try by all means to reduce these numbers, 25 and 15 into 3 and 5. That is the simplest numbers that we have. So if we are to take 25, we know that 25, that is 5 times 5, which is 25, which is 5 squared. So 25 is same as 5 squared. But take note, there is an exponent which is already there of negative x. So it is going to be like this, 5 squared to the exponent of minus x. So it will be an exponent and an exponent multiply to each other. So there we multiply the exponents, x to the exponent of a to the exponent of b, that is x to the exponent of ab. So this is going to be 5 to the exponent of negative 2x if you combine the two. So that means here we are going to have 5 to the exponent of negative 2x multiplied to 15. All right, 15 is actually we've got the prime numbers that we have here for 15 is 3 and 5. All right, I want you to see what is happening between on this 15 here. Okay, let me just remove so that we can work out the 15. The 15 that we have, it can be written as 3 times 5 in terms of its prime factors. These are the prime factors of 15, which is 3 and 5. So 3 multiplied to 5, but there is an exponent which is already there of x plus 1. So knowing that if we've got an exponent, the 3 is going to be raised to the exponent of x plus 1, which is the same way as 5, it is going to be raised to the exponent of x plus 1, from which law we've got x, y, if raised to the exponent of n, is the same as x to the exponent of n by y to the exponent of n. So that is the same scenario that we have. So it means we can rewrite 15 to the exponent of x plus 1 in this format as 3 to the exponent of x plus 1 times 5 to the exponent of x plus 1. Okay, everything over these two numbers, they are already in simplified form. So we're just going to rewrite as they are. So this is the given expression that you're going to have now. So from our laws of exponents, we know that if we are multiplying the bases which are the same, we are going to add the exponents. So that means we are going to have 5 to the exponent of negative 2x. The bases will remain as it is. All you do is to add the exponents. So if you're adding them, there's no need of you having brackets or this, just write the expressions as they are. So you're going to add to x plus 1 of this 5. But here we also have another 5 in the denominator. After dividing, we are having 5 to the exponent of negative x. So what is going to happen with the negative x that we have here, which is this 5? So if you divide, you subtract the exponents. So here we are going to subtract the exponent of negative x. This is what you're going to have. So take note, 5 is already having an exponent which is a negative, but the law states that we are supposed to subtract. So it's the negative for the law, then the negative for this x that we are given on 5. Okay, so we're done with 5. We multiply because here 5 was multiplying to 3. So we're going to multiply to 3 to the exponent of x plus 1, which is already given. But if we are to cross-check, there is another 3 that is dividing. So we are going to subtract the exponents just like what we did on 5 here. So we're going to subtract exponent of x. So here is just going to be x, direct x like that. All right, so from there, we're supposed to simplify as far as possible. Taking note that the negative and the negative here gives us a positive. So that means we've got negative 2x plus 1x, also plus another 1x. So it's negative 2 plus 1, which is a 0. Okay, or you can just test on your calculator. That's negative 2 plus 1, which is a 0. So here we are going to have a 0 on x. But we have got 1 here, which is not part of x. So this 0 plus 1, that is 1. So you're going to have 5 to the exponent of 1 multiplied to 3 to the exponent of, here we've got 1x minus 1x, that is a 0. 1 minus 1, that's a 0 there. So you're going to have 3 to the exponent of a 1. All right, so that's what you're going to have here. Knowing that 5 to the exponent of 1 is same as 5, 3 to the exponent of 1 is same as 3. So if you multiply 5 times 3, that is 15. So the whole expression that we see here is equivalent to a normal number, which is 15. Just imagine, guys. All right. So I don't know, there can be another way that you might be having or that you might be using to simplify this type of expressions. Okay, let me know on the comment section so that we can at least work with that method with others. It can actually help. It can actually help others if you've got another method. All right, but I think it was easier like that. And let's see, let me just remove this part so that we can check 1.3. On 1.3, we're given to determine the value of 3p plus q squared if we are given this expression is equal to 12 and pq is equivalent to negative 3. Okay, so here they are just trying to play around with you guys. All you need is to expand the given expression. So depending with the knowledge of your identities, remember from your identities, you can raise 3p to the exponent of 2, which is going to be 9p squared plus you multiply 3p and q, which is 3pq, then you multiply by 2. So it's going to be 6. So it's going to give us 6pq plus, then you raise q to the exponent of 2, which is q squared. All right, or you can just expand normally. Okay, 3p plus q into another bracket of 3p plus q. You then expand your brackets normally. That's 3p and 3p here, which is going to be 9p squared. Then now we move on to 3p and q, that is 3pq. So this is going to be plus 3pq. We are done with 3p. We move on to q. It has to multiply everything again in the second bracket. So that's q and 3p, which is 3pq. Then it's q and q here, which is q squared. So as you can see, we have put like terms, 3p and 3p, which is going to give us 6pq q squared. Okay, so this is pq, not 3p, 3pq. All right, so as you can see, you're obtaining the same expression just like what we did by using the identities of expanding normally. Okay, so from that part, you are supposed to now get back to this information that you're given, because you are given that if 9p squared plus q is equivalent to 12, so you are supposed to write this expression in this format. So you've got 9p squared plus q squared here. So we can rewrite this expression as 9p squared plus q squared, then we write 6pq at the end, because we are given pq is equivalent to negative 3. So you're supposed to substitute now in place of 9p squared. The whole of this expression is equivalent to 12. So this is 12 plus 6pq, that's 6 multiplied by pq. So you are substituting this pq here by a negative 3. So this is going to be plus 6 times negative 3, or you can just open brackets to represent negative 3. So that will be 12 plus 6 by negative 3, that is negative 18. So you've got a plus and a minus here, which is a negative. So it's 12 minus 18, which is a negative 6. Or you can just use your calculator. If you have forgotten the laws, that's 12 plus negative 18, like that. You are going to obtain negative 6. So that is the numerical value that you're going to have from the expressions that you're given. Now you are obtaining a numerical value of 6. All right, so you're going to cross-check another part that is on question 2. So that was question number 1. Let's just check what we had in terms of the marks. That was total 18 marks. So you can see, guys, just 18 marks, right? Which is a lot in exam. That's a lot. All right, on question 2.1, we are given on 2.11. This is to solve for x. So if we are solving for x, that is, you are finding the value for x. So on 2.11, we are given that px plus qx is equal to a. You are solving for x, but you've got other letters. We are not having numbers, we are having letters. So that is actually making x the subject. So here we've got x, which is common. So we can just factor out that x from your factorization. So if we factor out x here, we are going to remain with p. And on this part, if you remove x, you're going to remain with q, which is equal to a. Since we need x, these two, they're actually multiplying. So it's like x times p plus q. So to remove the p plus q, you just have to divide by that bracket throughout the given equation. So that cancels, and x is going to be equivalent to a over p plus q. So that is what you're going to have in terms of a, p, and q. All right, the other part was 2.12. That is a quadratic equation that you're given. So let's just remove this part. Okay, so this is 2.12, where we are given 2x squared minus 5x plus 2 is equal to 0. So for you to solve this type of equation, it depends with the method that you're going to use. Someone might want to use quadratic formula, but in this case, guys, because of the marks that you've got, supposed to use factorization method. Just try factorization. So on your factorization, this time the coefficient of x squared is no longer 1, just like what we had on that previous part where we just factorized direct. If I'm still having here, if you still remember what we did here, the coefficient of x squared was 1, so it was direct, you just open brackets. But now it's different because the coefficient of x squared, the number that is affecting x squared here, there is a 2. So you're going to do the longer way of factorization, where you multiply the first term to the last term. So it's 2x squared times 2, which is 4x squared. So this is actually positive 4x squared. So what you need is to find the factors of 4x squared. But these factors must add up to the middle term, which is 5x, negative 5x. So that's negative 5x. So for the factors of 4x squared, we only have two. There are so many, actually, 4x and x, negative 4x and negative x. We've got a 2x and 2x. So there are so many. I think these are the only factors that we have. But which of these factors that when you add them, they must give you the middle term, which is negative 5x. So you can actually try to add, that is, you're adding 4 plus 1, that is 5, not negative 5. Here we've got negative 4 and negative 1. So negative 4, negative 1, that is negative 5. So these are the two factors that you're going to replace. In place of negative 5x squared, we are going to now substitute or to replace it with these two factors, which is negative 4x and negative 1x, which is same as negative x. All right, so you have substituted or replaced the middle term, but the other numbers, they are going to remain as they are and also equal to 0. Remember, it's an equation. So just as you can see, we've got 4 terms, just like that part where we've got 4 terms. So now we can actually factor out for the first 2 terms, you group them into 2. 2x is common. So you can factor out 2x here, 2x and 2x, that is going to be x minus 4x and 2x. If you can see, x and x will cancel, 4 and 2, that is 2. So take note, you are supposed to obtain the same bracket, which is x minus 2, from these 2 terms that we have, which is negative x and plus 2. Our x here is a negative, but it must be a positive. So you are going to factor out negative 1 so that this x is going to be positive and 2 is going to be negative. So since the 2 brackets are the same here, hence we are going to have 2 brackets. We are going to factor out the x minus 2. Then the second bracket is going to be from 2x minus 1, the remaining terms which is 2x minus 1, you equate to 0. So that means each bracket is equal to 0 here. X minus 2 is equal to 0. Or another bracket of 2x minus 1 is equal to 0. So you're supposed to solve for x. All right, so I'm having O here, which is, that's a 0, not O. Okay, so from this part, if we are to transpose -2 to that side, it would be a positive, or x is equivalent to, let's start by transposing 1 to this side, is going to be positive. Then you divide by 2 both sides, so that will be 1/2. So these are the two possible values of x that we can have from that equation. So like I said, someone can actually want to use the quadratic formula to solve that. Yes, it's fine, but guys, because of the marks and that, it was easier for us to factorize. Okay, anyways, we shall work on quadratic formula on another platform, but for the meantime, let us focus on a factorization part. We are given on 2.13 to solve again for x. So we've got 1/2 to the exponent of 3x plus 1 equal to 32. If we are given this type, we are now back to exponents. 1/2 can be taken from this law. 1/x is taken from x to the exponent of -1. So if we are given 1/2 is the same thing as 2 to the exponent of -1. But taking note, there is already an exponent which is there, which is 3x plus 1. Then we can equate to 32. But since we have written this in terms of 2, let us have them in the same base, just like 2. So 32 in base of 2, that's 2 to the exponent of 5. So if you do not know this, guys, you have a trick. You can just try 2 to the exponent of 2, 2 to the exponent, until you have a number which is 32. So if you can see 2 to the exponent of 5 here, that's a 32. So you can try these numbers from the first one until you get a 32. That number that you have raised as the exponent is the one that you're going to use. So in this case, since the bases are the same, the 2 and the 2 are the same here, we are going to equate the exponents. We're going to equate these two exponents, which is -1 into 3x plus 1 is equal to 5. So you can expand the brackets, or you can divide by -1 both sides, depend with what you want. So let's expand by negative into 3, that's -3x, negative and 1, that's -1 is equal to 5. So you can transpose -1 to the other side of the equation, which is going to be a +1. So it's now 5 plus 1, which is 6. So to find x, divide by -3, which is affecting x here. The number that is affecting x is multiplying. So you just divide to remove that number. That's 6 divided by -3, which is -2. So that's the value of x that you're going to have. All right, so that's it, guys. 2.2, given that 3m minus 8 is greater than or equal to -8, but less than 4. So for m, so this is actually a simultaneous inequality that you're given, whereby you'll be given two inequalities. So let's just use this space here. We're given two inequalities to solve. That is 2.21. All right, so you've got a 3m minus 8, which is greater than or equal to -18, but less than 4. So you're solving for m in inequality. So if you are given this type of inequality, you separate the inequality by the middle term or the middle expression. So in this case, it's actually an expression which is in the middle. So that is the one that is going to separate the inequalities. So the first inequality here, we are going to have -11 less than or equal to 3m minus 8. So we have separated up to this expression. So from the other one, on the other one, we are going to start with that expression again, which is 3m minus 8 is less than 4. So this is what we have. So from that, we are going to solve separately. As you can see, it's now those basic inequalities that you are used to. So you can transpose -8 to that side. It's going to add. So it will be -11 plus 8 is less than or equal to 3m. So -11 plus 8, you can just add on your calculator, guys. If you do not know these values, that's -3. So -3 is less than or equal to 3m. Just like equations, you're going to divide by 3 both sides, and that is going to be m -1. M is greater than or equal to -1, maintaining the inequality sign as it is. You only change the inequality sign if you divide negative. So in this case, we didn't divide by any negative, so it's going to be like that. On the other part, we are going to transpose -8, which is a constant, to 4, so it's going to add. So that means we're going to have 3m is less than 4 plus 8, that is 12. So you can divide by 3 both sides, since 3 is multiplying here. So if we divide by 3, that is going to be m is less than 3 into 12, that is 4. So nothing changes. We haven't divided by a negative. So what you're going to do is to combine the two expressions, the two inequalities that you have obtained from this inequality that you had. Remember, we had two inequalities. So what you're supposed to do now is to combine these two inequalities, and always try by all means to start by the smallest number that you have. The smallest number that we have is a -1. So in terms of m, we are given that m is greater than or equal to -1. All right. The same m that we are referring to here, it's less than 4. So we're going to take from that m that we have here, which is less than 4. All right. So this is going to be m is less than 4. So as you can see, we are now having m represented as one single answer to refer. So you can actually read this as m is greater than or equal to -1, but m is less than 4. Okay, m is greater than or equal to -1, but m is less than 4. So that is actually what you're saying there. All right, on 2.22, we are now given hands. Whenever you're given hands, it's continue from there, which means from this answer that you have, that is where you're supposed to obtain this answer now. Write down the number of integers that satisfy the inequalities. The number of integers, how many integers satisfy this inequality? All right, we are given that our m in this case, okay, so this is 2 point, I can just use this space here. 2.22, we are given that our m is greater than or equal to -1, which means m is going to start from -1. From this expression, if you cross-check on a number line, we've got your -1 here and your 4. So this is what it means. We've got -1, we are going to shed here, and 4, we are not going to shed. So the numbers that you are going to take are going to range from -1 up to the number before 4, which is 3. So we are going to have, because we are referring to integers, these are positive or negative whole numbers. So our m is going to be -1. We move on from -1, that's a 0 there, up to 3. 1, 2, up to 3. So these are the values that are going to represent m, which is the inequality that we are given. Numbers which are greater than or equal to -1. But these numbers, they are less than 4. And we are referring to them as the integers. All right. So the question was, write down the numbers of the number of integers actually. How many are they? So it's 1, 2, 3, 4, 5. So which means we've got 5 integers in this case. If it was to list the integers or list the numbers, then we're supposed to write as m. Then you can write even in set notation, -1, 0, 1, 2, 3. So that is the set actually representing m. So but in this case, it was state the numbers. How many are they? That is the question. All right. So let's see the other part of the question, which is 2.3. We're asked out now to solve the simultaneous equations there. Solve simultaneously for x and y. So we've got simultaneous equations, which you can actually use different methods. You can work with the substitution method. You can work with elimination by substitution, so many methods. But in this case, I'm just going to try to work on substitution. Most of you guys, I see you love to work with substitution, so I'm just going to work with that. So in this case, we've got already 2 equations that we are given. So this is our first equation. Here, that's the first equation. And here we've got the second equation. So I want to utilize the second equation that we are given there. From the second equation, it is easier for us to make y to be the subject here. As you can see, guys, we can just transpose y to this side so that it can be a positive. Then we transpose 2x to the other side of the equation, which is going to be -2x. So y is going to be 3 minus 2x, which is now our third equation. All right. So from the third equation, we are going to substitute our third equation into the first equation. All right. So we substitute it into the first equation. Do not substitute into the second, because that is where you have made y to be the subject. So if you substitute back here, you're actually neutralizing everything. It's back to normal. So you substitute into the first equation. All right, so it's going to be 5x plus, in place of y, we are going to substitute the value of the expression, which is 3 minus 2x. All right, so we are going to have 4y here, which is 4 multiplied by 3 minus 2x, which is equal to 21. All right, since we are now having x, we can just expand brackets and solve for x. It's now a normal equation, the one that we are used to. So we are going to have plus 4 times 3, which is 12, 4 times negative 2, that is negative x. So we multiply by the number that is outside of the bracket. All right, so this is equal to 21. So collect like terms, we have got a 5x here and negative 8x. So you can subtract 5 minus 8, which is negative 3, or you can just use your calculator. 5 minus 8, that is negative 3x. All right, then we can transpose the 12x to the other side of the equation. That will be minus 12. So minus 3x is equal to 21 minus 12. So you can even use your calculator. 21 minus 12, that is positive 9. So you're going to have positive 9. Divide by negative 3 both sides, the number that is affecting x. All right, so if we divide here, x is going to be equivalent to negative 3. So that's the value of x. So you can divide from your calculator if you want to cross-check your answers. 9 divided by negative 3, that is a negative 3. Since we now have the value of x, which is 3, negative 3, we can now substitute into the value of y, or the expression for y, which is 3 minus 2x. Or you can substitute into any of these equations, but it is easier because already y is the subject here. So it's 3 minus 2 times the value of x, which is negative 3. So you can just use your calculator at once. It can simplify this for you. 3 minus 2 times negative 3. I'm just going to open bracket, put negative 3 here, close the bracket, which is 9. So y is equal to 9. So from this part, we've got a value of x as negative 3, the value of y as a positive 9. So what I want you to do is to work out this question with another method and see if you are obtaining the same answer. But if you're having challenges with that method, let me know so that we can work on that method on a separate class so that we can all revise and see what we had. So that was actually question 2, guys, having a total of 15 marks. So yeah, I don't know what you say about the questions. Are they easy? Are they easy enough? So actually grade 10 mathematics is something else. You need to revise as much as you can. It actually helps you guys as you are going, as you are advancing, especially these questions. They are very, very important. All right, on question number 3, you are given, consider an infinity linear pattern. So you're given a pattern which actually ends. If it is infinity, that one does not end, but this one is a finite linear pattern, or a sequence that we have. So from this part, we are given on 3.1, write down the fourth term of the pattern. So we need the fourth term of the given pattern here. All right. So what are you going to do? We can cross-check according to the expression that we are given. Okay, and just even utilize this space here. So from these numbers that we have, we've got 20, we've got 17, we've got 14, and so on and so on and so on, up to negative 1 or 3. So what you need is to check if this is linear. We already told it's a linear, so we are supposed to check for the differences. So we check for the difference between the terms, that is your T1, your T2, your T3, and so on, up to the last term, which is our Tn. We do not know the last term. So to find the difference D, we know that this is T2 minus T1. So you're going to subtract 17 minus 20, which is negative 3. So that means we've got a common difference of negative 3 here. If we do the same here, that's 14 minus 17, which is also negative 3. So the difference that we have here of negative 3 is the same throughout. So that difference is the one that was being added. We added 20 plus minus 3, and we got 17. 17 plus minus 3, we got 14. So that means the next term that we are going to have, it is going to have from the same difference of negative 3, but we're just going to add. So it's going to be 14 plus minus 3. So that's 14 plus minus 3. So you can actually check that one, guys. As you can see, it's actually easy that way. So that's 14 minus 3, which is equivalent to 11. So that means the 14th term of this pattern is 11. Then on 3.2, determine the expression for the nth term, that is the Tn expression. So I'm going to use this formula or this method. There are so many methods. I don't know what you have been taught, but there are so many methods that you can use to find the nth term. We've got this formula. Tn is equivalent to A plus n minus 1 times D, which is having A as the first term, n the number of terms, then D the difference. So that means your Tn is equivalent to A, that is the first term here, which is a 20 plus n minus 1 times D. Our D is the difference that we have. Take note, we obtained a difference of -3. So you're going to multiply by -3. So that is the expression for Tn, but you can't just leave it like that. Simplify as far as you can, guys. All right, so let's simplify. What is happening here? We have got a plus and -3 outside of the bracket. So this is going to multiply plus and the minus, which is -3. So the -3 is going to multiply the bracket here, which is -3 times n, that's -3n. -3 times -1, which is +3. So from there, we can actually collect the like terms. This is a 20, not a 30. Okay, that's a 20. It's because of the way that I've written there. So now we've got 20 plus 3, which is 23 minus 3n. So you can actually leave your expression as 23 minus 3n in this format. All right. So like I said, there are so many methods that you can use to find this one. Just have to work from there. All right, 3.2, calculate the number of terms in the sequence. Okay, from the sequence that we have, how many terms do we have? So take note, this one is a finite linear, which means it ends at 1, -1, or 3. So where it ends, that is our last term, which is equivalent to Tn. So in this case, we can refer our Tn. So this is 3.3. Okay, that's 3.3. So you can refer our Tn as the expression that we are given. Remember, it was 23 minus 3n before. That was our Tn. And now we are given that the last term from the sequence that we are given here is -1 or 3. So that means your Tn is equivalent to the last term, which is -1 or 3. So if Tn is equivalent to the last term, which is -1 or 3, then we can calculate the number of terms because these two, they are equal. So we can equate 23 minus 3n to -1 or 3. So we can calculate how many terms we have. So you can transpose 23 to the other number, which is -1 or 3. So we are going to remain with -3n, which is equal to -1 or 3, -23. So -3n is equal to what from our calculator here? -1 or 3 minus 23, which is going to be -126. So we can divide by -3 both sides. All right, so that's n is equivalent to -126, the one that we already have here, divided by -3, that is 42. So which means we've got 42 terms in this sequence that we are given in this linear pattern. There are 42 terms. All right, so that is what we had. On 3.4, we are now given which term is the first to have a negative value. All right, guys, we can't there are so many terms here. So it depends with your patience. Some can even try to write the numbers from 20, 17, 14, up to that term, which is going to be a negative, and count the number of terms. How many terms are there to that first term? That's going to take a lot of time. So what can we do to avoid that? We are given that in this term, the first term that we are supposed to have, it is supposed to be a negative value. We know that our numbers are being determined from 0. From any number from 0 going to this side, we've got numbers greater than which are positive. And from these numbers, we've got numbers which are negative. So any number that is negative, it simply means that number is supposed to be actually less than a 0. So we are referring to which numbers that we are going to have, which is less than a 0. We are referring to our Tn to be less than 0. The term that we are supposed to have must be less than 0, because take note, which term is the first to have a negative. So we are referring to the term. So our Tn is supposed to be a negative that is less than 0. Okay, so having this is going to be an advantage It's going to be a great advantage. All right, so which advantage is that? Okay, let me see. Let me write it here so that we can see the advantage now. So since we are saying Tn is supposed to be less than 0, that means we can take the Tn that we originally had before this Tn, which is 23 minus 3n. So that means 23 minus 3n is less than 0. So you can solve here from this expression. Negative 3n is less than, we can transpose the 23 to the other side is going to be negative 23. So this will be negative 23. Divide by negative 3 by negative 3 both sides. So n is less than, this can cancel, which is 23 over 3. So let's actually see in terms of the number actually so that we can compare the numbers. 23 divided by 3 is same as 7,666 and so on and so on. So it's 7,666 and so on. So we are referring to the numbers which is less than. Right, where did we get? Okay, we divide, guys. Sorry. I hope someone actually saw this. What is happening? You say, all right, you say actually got something here. If you are actually dividing here by negative, this will be a greater, it will reverse. So let me actually indicate this. This is actually a mistake. So let me indicate this way. So this is a greater than, all right? A greater than. The moment you divide by a negative, the inequality sign has to reverse. Guys, please take note of this. Whenever you divide by a negative sign, the inequality sign reverses its sign, all right? So referring to numbers which are greater than 7,66 and so on, definitely these numbers are integers. So which number is greater than 7,66, which is an integer? Definitely that number is 8. So n is equal to 8. So which means from the term, from the eighth term, that is where we are having a negative answer. All right, so that is what you're going to have in this case. The 3.5, we are now given what is the value of the 19th term, even valued term in the sequence. So we are working with the even numbers. All right. So for this type of an expression, this type of equation, it depends with the way that you're going to use. How are we going to work it? We can take back to the normal way that we used here to obtain Tn. For the normal expression, remember this was the formula that we used to find Tn when it was a normal expression. But now it's no longer a normal expression because the even valued numbers are the ones that we are working with. We are working with what? We are working with the even numbers. That is numbers such as 2, 4, 6, and so on. So the even numbers, if we are to check their order, the first, we have got 20 here, followed by 14, followed by the other number that we are going to have and so on. We do not know these numbers. So definitely the pattern is going to change because we are now having the first even number here. So this is 3.5. The first even number is 20, followed by 14 and so on. So this is the pattern that we are going to have for the even numbers. So the question is referring for you to find what is the value of the 19th even term. So which means we need T19. But remember that our Tn from that format that I have written, I wrote it as A plus n minus 1 times D. That was our Tn. But our n in this case is 19 because that's the 19th term. So we can refer to our T19 as A, which is the first term, which is 20 here, plus n minus 1. Our n is 19. So it's going to be 19 minus 1 times D, which is the common difference. So the D here is the difference. So it has changed because we started with 20, followed by 14. What is the difference between the two? Not forgetting that the common difference D is given by T2 minus T1. You just have to subtract 14 minus 20, which is a negative 6. So that's a negative 6. So we are going to have negative 6 here. All right, so it's an expression that you can actually obtain direct on your calculator, or you can simplify first. Here I've got 19 minus 1, which is 18. So the D that you were having, the negative 6, is actually multiplying. This one is multiplying. So it's going to be 18 by negative 6. Okay, so you can just even use our calculator here. 18 by negative 6, that is negative 108. So this is going to be negative 108. So take note, it was a positive and a negative, so it will be a negative. So 20 minus 108, that is 20 minus 108, which is actually negative 88. So this one is going to give us negative 88. So that is our T19 in terms of the even numbers. And if we can check, negative 88 is it an even number? Because you might obtain a certain answer, then you checking at that answer, you see that it's not an even number. That means it's actually wrong. But if you can check, it's actually an even number. So that means we're in the right direction. But like I said, there are so many methods or ways of using this or finding this. So as time goes on, guys, we shall be working with different methods. Let us know those methods so that we can work with them for your benefit, guys. All right, question 4. All right, so this person is actually 10 marks. All right, he saves it. Okay, on question 4, we are given Samantha is investigating a pattern of dots represented in the diagram below. Okay, so the pattern, we've got the first one, second one, and third one. So as you can see, we've got first dot, which is 1 squared, 1. Then here, the first layout, second one, 1 plus 3, which is 2 squared, which is 4, and so on and so on. So you can simply see that here we've got 1 squared. Okay, we've got 2 here, we've got 2 squared, we've got 3 here, we've got 3 squared, and so on. So which means if it is 4, it is going to be 4 squared, and so on and so on and so on. All right. So the question is on 4.1. Write down 4.11, the number of dots in the 40th pattern. All right. So definitely that is the 40th pattern of 4 squared. So this one is going to be 4 squared, which is 16. So this is direct, guys. We can just check what is happening there. 4.12, the number of dots in the 13th pattern. So it's simply 13, that's like what we had. So it's 13 squared. 13 squared, that's 13 times 13, which is 169. We can even use your calculator. 4.13, a formula for the number of dots in the nth term. The nth term is just like what we had on 4 squared, 5 squared. So if it is 5, it's going 5. So if it is n, it's going to be n squared. All right, so this is now n, so it's going to be n squared, just like what we had from the other ones that we had. All right, so on 4.2, we are now given hence or otherwise, which means we can use any other platform or any other way of calculate the value of. All right, so you're given a pattern 1 plus 3 plus 5, and so on and so on and so on. We do not know what is happening, but what we need is that we have taken from this part, or we have seen from this part, that for any value of n that we are going to have here, for any value of n, if it is the nth term, we are going to square that value of n. So what you simply need is to find the value of 10 and the value of n from this sequence that you're given. It's a sequence that you have. So you check, it's a linear pattern. We also have got 1, 3, there's a difference of 2 here. 5 minus 3, that's 2. So you can see there's a difference. So it's a linear pattern that we have. So from our linear pattern, remember what I said? I said Tn is equivalent to A plus n minus 1 times D. So in this case, your Tn, remember what we need is to find n. As long as we can find n, we are going to square that n. So to find n, we are going to substitute all the information that we have. Tn represents the last term that we have, and in this case, our last term is 43. So we are going to write 43 is equal to A. Remember, A is the first term. So this is your first term. And the first term here is 1. So it's equal to 1 plus n minus 1. We need to find n. So we do not know the value of n. How many terms are here? We do not know. B is the common difference, the one that made us to use this formula, the one that we had in the first place, which is the 2, the common difference. So that is our D, which is 2. So we have formulated an equation from this formula by just substituting the values that we are given so that we can calculate the value of n. By knowing the value of n, then we can simply square that n, because we said the formula for the number of dots is simply found by squaring n. All right, so let's find n, guys. What are you going to do? We can transpose 1 to this side, which will be minus 1. So 43 minus 1, that is 42, is equal to n minus 1 times 2. So you can expand the brackets by 2, or you can divide by 2 since it is multiplying. So you can cancel 2 and 2. 42 divided by 2, that is actually 21, is equal to n minus 1. Okay, That's it, guys. We can just use your calculator. But as you can see here, 2 into 4, that is 2, 3 into 2, that is 1. All right, so to find n, we are going to transpose -1 to this side, which is going to be a plus. So n is going to be 21 plus 1, which is 22. But the question is, we are supposed to calculate the value. If you add everything, what is the value? So the sum of everything is simply found by n squared from that formula that we got. So our n squared is going to be equivalent to 22 squared. That is 22 times 22. Okay, just a calculator, or you can multiply. Yeah, some guys, they can do that, which is 484. So that was it, guys. As you can see, simply clear. All you need to is to revise as much question papers as you can. So that was actually 6 marks on question number 4. Let's check what we had on question 5. That is functions. So we are given, sketched below, the graphs of f of x, which is equivalent to ax squared plus q. Then we have got gx. So we've got f and g here. All right, so let's see what we have. Let's try to reduce this so that we can see the graphs. Okay, so these are the graphs, guys. That's our f here and the g. So we are given that the graphs intersect at A, and the point E is given as 1, 3 lines on F. C is the turning point, that is the point C. So C is actually the turning point, and it's also the y-intercept there of what? Of F, as you can see. And D is the y-intercept of G. Okay, D here is the y-intercept of G. Okay, so it was direct. So the first question on 5.1 was write down the coordinates of D. Write down the coordinates of D. All right, where can we obtain D? D is the y-intercept of G, and we are given that Gx is half to the exponent of x minus 1. Let's just write this down. Okay, let's just write it here so that it can help us. So Gx was equivalent to half to the exponent of x minus 4. Is it minus 4 or minus? Yes, that's minus 4. All right. So this is your Gx. And if we are to cross-check, where do we have our D? D lies on the y-axis. This is the y-intercept, where we know that in the y-axis, x is equivalent to 0. In the x-axis, y is equal to 0. So we can take that advantage to say that x is equal to 0 in the y-axis. So if our x is equal to 0 here, that means y is equal to half to the exponent of 0 minus 4. All right. So that's what you're going to have here. All right. So half to the exponent of 0, that's any number to the exponent of 0, that's a 1. So which means we're going to have 1 minus 4, which is -3, or you can just use the calculator at once. That's 1 over 2 to the exponent of a 0 here. Whatever that we have, we subtract 4. That is a -3. So we're going to obtain the same answer. So that's D. Remember, we said x is equal to 0 in the y-axis. So that means the point D is going to be x, which is 0, and y is -3. Remember, a point is supposed to be made x followed by y. Okay. Then on 5.14, we are now given 5.12, the range of g. All right, g, we are given our g as an exponential function, and the range is actually taken from the values of y, and the values of y are not going to exceed the asymptote in terms of y. So this is where we have our asymptote in terms of y, and the asymptote is taken from the equation, or from the expression, from the function, which is the -4. This part here represents the asymptote. So it means this line is of y is equal to -4. That's where we have the asymptote. Okay, so if you can have your gx as any part, we can have as a to the exponent of x plus b. The b that we see here is the asymptote in terms of y. So y is equal to -4. So that means the range now, comparing our g, we can see that our values of g, they are above -4. We've got -4 here. We've got -3, -2, -1, 0, 1, 2, and so on and so on. So these values that we see, they are above the line of y is equal to -4. So they are above. If they are above -4, that means they are greater than -4. So we're actually going to refer to the values which are greater than -4. So that is what you're going to have in terms of y, the values which are greater than -4. All right, so that means the range on 5.12, we are referring to the values of y which are greater than -4. They won't be equal to -4. So there is nothing like greater than or equal to 4. It's an asymptote. Remember, an asymptote, that's a point or a line where the graph is not going to reach that. It will never reach that one. So which means y is greater than -4. All right, on 5.2, calculate the 5.21, the coordinates of A. So you're supposed to calculate the coordinates of A. Where do we have the point A? A lies on G and also lies on F. This is where we have our A. So we can take advantage of G since we do not have anything on F. F is simply naked. We do not have anything. There is nothing that we have. So there's nothing we can get from this one. So we can utilize what we already have on G. So this is 5.21. So utilizing what we have on G, we can see that our Gx is equivalent to half to the exponent of x minus 4. And the point A that we are referring here lies in the x-axis, where I said in the x-axis y is equal to 0. So if y is equal to 0 here, that means we are going to have, in place of gx, that's our y, so 0 is equal to half to the exponent of x minus 4. So what are you supposed to do? Supposed to solve the equation in terms of x for x here. So let's solve this equation for x. As you can see, it's now a normal equation, but it's an exponential equation where you can transpose -4 to the other side of the equation here so that it can be a positive. So we've got 4 equivalent to half to the exponent of x. From our exponential equation, we understand that the bases must be the same. So we talked about this previously of 1/2, that is the same as 2 to the exponent of -1. So this is same as 2 to the exponent of -1x, which is -x. All right. And 4 is same as 2 to the exponent of 2. So as you can see that the bases are the same. So you're simply going to equate the exponents. So by equating the exponents, 2 is equivalent to -x. So to find x, simply divide by -1 both sides. So x is going to be -2. So that is what we have for the point A. So therefore, the point A can actually be written in this form. Since x is -2, y was equal to 0, so the point is going to be -2, 0. Remember what I said about the point is supposed to be x followed by y like that. All right, so that was 5.21. The coordinates of what? Coordinates of A. 5.22, the values of A and Q. All right, so what are you going to do to obtain the values of A and Q? The values of A and Q, they're actually taken from the quadratic equation. Okay, let's see where we have our quadratic here on top, which is f of x is equal to a x squared plus q. All right, let me just write it aside here. If we can have some space to work it out. So on 5.22, we are given that this is f of x, actually. Okay, this is f of x, which was ax squared plus q. All right. What we need, or what do we have so far? We have determined the point A, the point E. All right, we remember the point A, it lies on F and also on G, and it's -2, 0 here. We determine this point as -2, 0. And we also have the point E, which lies on F, which is 1, 3. So having these 2 points, we can actually work something from these 2 points because we do not have anything that we can work with. We do not have the turning point, or we do not have the solutions actually for this function. So we are going to work with these 2 points, A and point E. All right, so here is our function. So like I said, we are going to work with the 2 points, which is point A and point E. Remember that our point A was -2, 0 and point E was 1, 3. So these 2 points, they're actually representing the values of x and y. So you can just substitute into the equation since we have f of x is same as y is equal to ax squared plus q. So let's substitute the point A where y is equal to 0 and x is equal to -2. So in place of x, this will be -2 squared. So we can have something like this, a by -2 squared plus q. All right, so q, there's nothing that you're going to substitute here. So 0 is equal to -2 squared, that is 4. So it is going to be 4a plus q. All right, using the same concept, we can do that for the point E. Okay, we are given that on point E that y is equal to 3. So y is equal to 3. So 3 is equal to x being 1. So we are going to substitute x as 1. So this is going to be 1 squared plus q, which is 3 is equal to 1 squared. That's 1 times a, which is a plus q. So we are now having two equations. Actually, we've got the first equation here, the second equation here. So if you cross-check the first part that we solved simultaneous equations there, we had to use substitution method. So I think now we are used to that part. So I'm going to avoid using substitution method. I'm going to work with elimination this time. The first equation we are given that 0 is equal to 4a plus q. Then the second equation 3 is equal to a plus q. So that's our first equation, and that's our second equation. So we can take advantage since here you can see that we've got q and q, they are actually the same. So we can subtract the second equation from the first equation. That's 0 minus 3, which is negative 3, is equal to 4. So if you're subtracting, you subtract throughout. So this is going to be 4 minus 1a. So this is same as 4 minus 1, which is 3. So it's going to be 3a. Q minus q, that's a 0. So to find a, you simply have to divide by 3 for sign. So x is going to be equivalent to negative 3. So to find the value of, okay, this is a, not x. So to find the value of q, you're just going to substitute into any of the value of a into any of these equations. So you can even use the first equation where we've got 0 is equal to 4a plus q. And we've got our a as negative 1. So this is going to be negative 1 here. So that means 0 is equal to 4 times negative 1, which is negative 4 plus q. So to find q, you're going to transpose negative 4 to the other side of the equation. That's 0 plus 4, which is 4 is equal to q. So these are the values of a and q. Q is equal to 4, and a is equivalent to negative 1. So that's actually what we had. So the question was just for you to calculate the values of a and the values of q. So you can even substitute these values of a back to the equation. So because we might need to use this one. All right, but let's see if we are going to use these values later on. All right, so that was 5.22. If you are to cross-check the other part on 5.3, what 5.31, the length CD. Okay, the length of CD. Okay, let's check what we have. We do not have the point C. Okay, we do not have this point C. The point D we have, remember we calculated D before we got 0 minus 3. So we put minus 3 here. It's actually a straight line in the y-axis. So by just finding the value of C here, it's going to be easier to find CD. All right, so what are you going to do? Remember, we have the values, I think these values, okay, they are here. We have got the values of A, okay, the values of P and Q, we calculated them. All right, we ended up here. All right, this is too far now. All right, so I'm just going to take these values of A and Q, which is minus 1 and 4. All right, so that's minus 1 and 4. So let me just take them here, guys. This is now too far. Let's just do it here. All right, so this is 5.2, 5.32. So like I said, we are going to substitute now the values of A. Our A was equivalent to negative 1, and our Q was equivalent to 4. So we are going to substitute into our f of x so that we can find the point C. So A is negative 1, which is negative x squared, plus Q, which is 4. So C is the y-intercept, where we know that in the y-axis, x is equal to 0. So if x is equal to 0, that means y is equal to 4. So the point C is actually 0, 4. That's the point C, that's 0, 4. So we are going to take back our point C here, which is 4. All right, so this is where we have our point C, which is 4 in the y-axis. All right, sorry for that. So in the y-axis, the distance that you're going to have from C to D here, you simply have to subtract because you're going down. So it's 4 minus 3. So that is the distance that you're going to have for CD. All right, so going far here. So CD is going to be the y value for C minus the y value for D, which is the ones that we had. Okay, so it's the y value for C minus the y value for D. The y value for C, that is 4, minus the y value for D, that was a negative 3. Remember, your D is negative 3, guys. So that's your CD, which is plus. Negative and negative is a plus there, which is 4 plus 3, that is 7 units. So that means CD is actually 7 units from where we have. So that was our 5.32. Let's check 5.31. Then 5.32, we are now given to find the equation of a straight line which passes through A and D. So we need the equation of a straight line through A and D. So do we have the point A? Do we have the point D? If we have these points, then it's fine. Okay, the point A is negative 2, 0. The point D is 0 minus 3. So it's fine. Okay, if we've got this point, then we are fine. We can even do this question here. Because we've got these points, there's no need for the graph on this one. All right, so that was 5.32. So the point A, we had it as negative 2, 0, and we agreed that the point D is 0 minus 3. So this is the equation of a straight line, which we know that the equation of a straight line is given by the formula y is equal to mx plus c. So there's a definite need for you to find the gradient. Yeah, we need to find m, which is the gradient. So the gradient from A to D, the gradient of line AD can be taken from the points x1, y1, x2, y2, which is the formula. The increase in y, that is y2 minus y1 over x2 minus x1. All right, so we can substitute. That's the gradient of AD is equal to y2, which is negative 3, minus y1 here, that's 0, over x2, that's 0 minus x1, which is negative 2. So that's negative 3 over 2, which is okay, we can just use a calculator direct. Okay, if you are that person of a calculator, that's negative 3. All right, that's negative 3, negative 0 here. Whoa, where's my fraction? I need the fraction first. All right, negative 3 minus S0 here over 0 minus 2. That's negative 3 over 2. So having the gradient, we can substitute this gradient into the equation that we have. Remember, we said y is equal to mx plus c. So y is equal to m, which is the gradient of negative 3 over 2x plus c, which is the y-intercept. So this part, we had the advantage that the c is the y-intercept, which is on point D. The y-intercept is negative 3. So therefore, your equation is going to be negative 3 over 2x minus 3. All right, let's say you did not recognize that that's your y-intercept. What you're going to do, you substitute any of these points. You can substitute A, you can substitute D, any point. Okay, let's substitute A and see what you're going to have. Y is equivalent to negative 3 over 2x plus c. So on point A, y is equal to 0, and x is equivalent to, the value of x is minus 2. So it's going to be minus 2 plus c. So you can simplify here, which is going to be negative 3, or you can use your calculator, negative 3 over 2 times negative 2, which is going to be positive 3. So 0 is equal to 3 plus c. So to find c, definitely transpose 3 to the other side, which will be negative. So as you can see, we are obtaining the same value for c, which is negative 3, as the one that we had on the y-intercept. So that's the equation of line AD, which is going to pass through that with the points A and D. 5.4, for which values of x is 5.41, f of x greater than 0. Okay, so there we need the graph. Let's check where f of x is greater than 0. Okay, from our graph here, this is our f. Our f is greater than 0. You see it by the line here. We've got y is equal to 0. Okay, from this y is equal to 0, we're going to have negative 1, negative 2, negative 3. On the top, we're going to have 1, 2, 3, 4, and so on. So y is greater than 0 above the x-axis, which means from this negative 2 here up to the value at point B here. So actually, we do not know the point B. So far, we do not know the point B. So where are we going to have the point B? We never calculated the point B before. So that means we are supposed to calculate that point B. So to calculate the point B, we can get back from the equation that we had. All right, so we can take back from that equation. Let's just calculate the point B. All right, where is our equation? Okay, there are so many values here. We can even use this part here. I think there are so many things that we have done. All right, but still it's fine. All right, let me just do it on top. Why not just calculating here? It's fine. Let's just calculate it here, guys. All right, so because we've got a space here. So remember that our f of x, this is 5.41. All right. You can even utilize this space. we are given the condition where f of x is greater than 0. And I was referring from A to B here. That's where it is actually greater than 0, above the x-axis. But we do not know the value of B. So from our f of x, the original equation that we had, remember, when we substituted that f of x, we ended up having minus x squared plus 4. So these are the x-intercepts, A at the point A and B, where y is equal to 0. So if y is equal to 0, that means we are going to have 0 is equal to negative x squared plus 4. So you can transpose negative x squared so that it can be a positive, which is equal to 4. So find x, simply the square root of both sides. So x is going to be the square root of 4, which is plus or minus 2. So x can be equal to minus 2 or can be equal to positive 2. So the minus 2 is the one that we have at A, which means at B here, we've got a positive 2. So the question is, for which values is f of x greater than? So x is going to be greater. We are referring to the values of x now from minus 2. We've got minus 2, minus 1, 0, 1. So these values, they are actually greater than negative 2, but less than positive 2. If this question was given as f of x is greater than or equal to 0, your answer was going to be x is greater than or equal to minus 2, less than or equal to 2. So you now write the equal to on your answer. But in this case, it was greater than. So there is no need, you do not put that greater part. Okay, so that was 5.41. Let's check the last part, which is 5.42, guys. Okay, we've taken this a lot. Oh, where am I going? I'm still going down and down. Okay. For which values of x is f of x increasing? All right. For which values of x is our f decreasing, not increasing, decreasing actually. So you want to see where f is decreasing, where x is starting to be decreasing. Okay, let's see. Oh, let's see. Where do we have our f? This is our f here. Cross-checking on our f, we can see that, let's check from the beginning here. Here is our f. It's increasing, it's going up, it's going up, it's going up, it's going up to C, which is the turning point. Remember, at the turning point, the graph is stationary, or the function is stationary. Once it moves from this C, it starts now to decrease. You're going down, 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 down. So which means at this point where x is equal to 0, at this point, it is stationary. The moment it moves from 0, let's say 0, just from 0, smallest number that you can think of, the function is now decreasing. It is now going down. So that means our x is supposed to be greater than 0. All right, so that was 5.42. So x is greater than 0. All right, so that was it, guys. Okay, as we can see, that's what we had on question number 5. Let's see as the total, what we actually had, the total there. So it was actually carrying 17 marks. Yeah, it had a lot. It had a lot. Actually, it was taking 17 marks. All right. So let's see the other part of the question, which is the next one. All right. Let's see question 6. On question number 6, we are now given the equation of the function gx is given as a over x plus q. So there we are actually given a hyperbola from our hyperbola function. Some they can write this, they can refer this as inverse functions, which is a hyperbola. That's a hyperbola. Okay, still one in the same way. So from the hyperbola that we are given that gx is equivalent to a over x plus q passes through the point 3, 2, and here's a range. This is the range. So from our range, take note, it ranges from minus infinity to 1 and 1 up to positive infinity. So the 1 that we see here is affecting the value of y, which is the asymptote in terms of y. So this one is actually your asymptote, where y is equal to 1. And we know that the asymptote affects the value of q here, so which means also q is equal to 1. Okay, I'm just referring to the given information. It's not about the question that we have been asked. Okay, so let's check the first question now. The question is determine the equation of g. Okay, we're asked to determine the equation of g. Okay, so using some of the values that we have talked about the q there, we can actually continue from there. All right, so this is 6.1. I'm going to have our gx from where it was 6.11. We are given that our gx is given as a over x plus q. All right, and so far we said q is equal to 1 from the asymptote from the value of y, which is the asymptote. X would be equal to 0 at the asymptote. As you can see, we are just having x here. So x is direct equal to 0. All right, so that's what we have. Okay, this one is not going to help us for the meantime. I'm just referring, maybe we might use this later on. All right, so since q is equal to 1, that means we can rewrite our gx as a over x plus 1. All right. And there's a point that we are given on G. Here we are given that there's a point here passes through the point 3,2. So the point 3,2 can work out something to find the value of A, because we are left with A and we are given that there's a point 3,2 where the graph passes on. So give the point represent the value of X and the value of Y. Gx is same as Y is equal to, so in place of Y, we're going to substitute 2 is equal to a over x, and our x is 3 minus, okay, that's a plus 1. Okay, so for us to solve here, we can transpose the positive 1 to this side, that's a negative 1. So that's 2 minus 1, which is 1 is equal to a over 3. So to find a, you can just cross multiply both sides. 3 is equal to a. So that means if a is equal to 3, therefore gx is equal to a, which is 3 over x plus q, which is 1. So that is the equation that we are asked here. All right, the other part of the equation, determine the equation of h. So take note, we are dealing with h, the axis of symmetry of G, with which has a positive gradient. Okay, remember, if you are dealing with a hyperbola, you'll be having something like this, and there will be the axis of symmetry. So the one with the positive gradient, we see it from the x. Remember, from our y is equal to mx plus c, but that one, it will be y is equal to x plus c. Already, it's either it is y is equal to minus x plus c or y is equal to x plus c, where as long you are dealing with the axis of symmetry. So don't worry with the mx plus c, there's nothing like that. We're just writing direct as it is. All right, so that was 6.12 now. So 6.12. So we know that the one that has got a positive gradient is given as y is equal to x plus c. So to find c, you are going to take the point, which is the asymptote. At the asymptote, that's where this line passes through the axis of symmetry. It passes through the asymptote. And we talked about the asymptote. We said x is equal to 0, y is equal to 1. So it's a point that we are going to substitute, which is 0, 1 at the asymptote. All right. So from this one, our x here, that's x and y. So we've got x and y here. So you can substitute. The value of y is 1. So 1 is equal to x. That's as 0 plus c. So that means c is equal to 1. So therefore, the equation is going to be y is equal to x plus c, which is plus 1. So that's the equation of the x of symmetry, which has got a positive gradient. On 6.2, we are now given to sketch the graphs of G and H on the same system of axes. Clearly show all the asymptotes intersect with axes, and that 4 marks for that. All right, so that's a sketch that you're going to have. So you've got, all right, so this equation was for H. All right, so this equation for H, so y is equal to its H. So this is hx, which is x plus 1. Okay, so now in 6.2, we need to sketch these two graphs that we have. So we've got some of the information that we have before from our gx here. Let's just have this as 6.2. So we're going to take some of the information that we already determined from the previous part. All right, I hope I'm going to put, I'm going to have a nice part here. So remember, from our gx, we had this as 3, it was 3 or 2. Okay, that's 3 over x plus 1. We have got 3 over x plus 1 over x plus 1 aside, not x plus 1 like that. So this is 3 over x plus 1 like that. And already we have got our asymptotes here, where we said x is equal to 0 and y is equal to 1. So far, this is what we have. And on hx, we are given that hx is x plus 1. So let's calculate for each graph what is necessary. All right, for the hyperbola that we have here, we are supposed to have the x and y intercept. So but we can't have the x-intercept because we have got an asymptote at x is equal, which means it will not never pass this part. So we are just going to focus with the y-intercept, where we know that x will be equal to, no, the x-intercept, the x can't be equal to 0. So we are going to find the y, the x-intercept. All right. So sorry for that, guys. So that means here we are going to calculate the x-intercept where y is equal to 0. All right. So when y is equal to 0, you can just substitute here. Y is equal to 0. That's 0 is equal to 3 over x plus 1. So you can transpose 1 to the other side. That would be negative 1 is equal to 3 over x. So to find the x, what you need to know is that negative 1 is same as negative 1 over 1. So what you simply do is to cross multiply so that you can find x. So it's x times negative 1, which is negative x is equal to 3. So to find x, you can divide by negative 1 both sides. That's x is equal to negative 3. So that's the x-intercept. That's the only x-intercept that we can have at x is equivalent to negative 3. All right, so let's start with this one first. Let's start with this function. So this is a sketch actually, but you guys, you're supposed to have something which is nicer than this one. Okay, let me try to just focus a little bit. All right, let's see. So this is what you're going to have for the hyperbola. What we need first is the shape, how it's going to look like, and also the asymptotes. So according to the positive that we have here, the number that you're given is a positive 3. So you're going to expect something of this nature. Okay, it's a curve like that. All right, so you can even name your values 1, 2, 3, 4, 5, 6. So negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, 5, and so on and so on and so on and so on. Negative 4, negative 5, and so on. All right. So on this part, we've got the asymptotes at x is equal to 0. X is equal to 0 is the y-axis, so it is not going to pass through the y-axis, okay? And y is equal to 1. Y is equal to 1 at this point, so that's an asymptote, this one. Y is equal to 1 is an asymptote. All right, so we've got y is equal to 1 as an asymptote. All right, so the graph is not going to pass through this line and also through the through the y-axis. We are given the x-intercept at negative 3, so we've got our x-intercept here at negative 3. So remember the shape that you're supposed to have this type of a curve here. So according to the curve, it is going to be like it need to approach the y is equal to 1, but it will not approach this line. At -3, it also won't approach the y-axis. Remember, y-axis is an asymptote. So it will be, we're going to have a shape like that. And the second one definitely is going to be in this quadrant because it won't exceed y-axis and it won't go below y is equal to 1. So we shall have a curve on the remaining region here like this. All right, so that will be our function representing gx. All right, so this is our gx. You can even write g on any of those. All right, then let's focus on h. hx is equal to x plus 1. So we can just find the x-intercept where y is equal to 0. So when y is equal to 0 here, we are going to have 0 is equal to x plus 1. That's x is equal to -1. So x will be equal to -1. Then for the y-intercept, x is going to be equal to 0 this time. So if x is equal to 0 here, that means y is equal to 0 plus 1, which is 1. So our x-intercept is at -1, okay, which is somewhere here. That's -1 here. Y-intercept is at +1, which is here. So we're just going to join these points, -1 up to 1 through passing through 1 and so on. All right, so this is going to be your h, which is x plus 1. All right, so that was the sketch. Yeah, something like that. I think it's clear. Then on 6.3, we are now given that on 6.3, right? The equations of the asymptotes of f of x, if f of x is negative gx plus 5. All right, we need where there is gx so that we can do this one, 6.3. So Where do we have gx? Here is our gx here. All right, we've got our gx as the expression or as the equation 6.3. So remember that our gx previously was 3 over x plus 1. All right, that's it here. 3 over x plus 1. So the question is for us to determine or to have the asymptotes when for f of x, if f of x can be written as negative gx like this plus 5. So the question is, we already have gx, so let's find f of x first so that we can find the asymptote. We can do that. So let's find f of x first. So that means our f of x here can be written as negative gx. This is our gx, the whole of this expression, which is 3 over x plus 1 like this, plus 5. So whatever that you're going to multiply on gx, you add a 5. All right, so let's find f of x. Multiply by negative, it is going to be negative 3 over x. Multiply by negative on positive 1 is going to be negative 1 plus 5. So that means f of x is going to be negative 3 over x, negative 1 plus 5, that's a positive 4. So we are now having a new equation representing a hyperbola where our asymptotes now taken from x, x is going to be equal to 0, and y, we are taking the value of 4 as it is, which is y is equal to 4. So that is going to be, those are going to be the new equations now for the asymptotes. All right, so that's how you simply attempt those typical questions, guys. If you're given something of that nature, that's what you simply do. You just have to work on much questions. Much question papers actually do as much question papers as you can, guys. All right, on question 7. All right, let me just try to remove this part a little bit here. All right, so you're given on question 7, read the advertisement below. Buy a Samsung J5 for only 229 Rand per month. You have 24 months to pay. No deposit is required. That is the advertisement. On 7.1, we are now given, calculate the total amount to be paid over the period of 24 months. So we are given here, guys, that this is going to be 229 Rand per month for 24 months. So simply you're going to multiply 229 Rand by the number of months that you're going to pay, which is 24 months. So that's you and your calculator there, 229 multiplied by 24, which is something like 5,496. So it's 5,496 Rand. All right, so that's what we had. On 7.2, we are now given the monthly installment quoted in the advertisement. Okay, there's a monthly installment that we are given, which is 229, is calculated on a hire purchase agreement. So take note, this is a hire purchase agreement, which charges interest of 7.5% per annum, that is per year, on cash price of the cell phone that you are given. Show that the price of the cell phone is 4,700 and whatever that we have. Okay, so they are saying that if this is actually a monthly that we are given, so it means after the period of 24 months, after 2 years, the total amount was supposed to be 5,496 with this interest, like we are now taking as it is an interest. So that means this is the amount that actually accumulated to, the amount that we need to accumulate to, which is the 5,449. Okay, this is the amount that we have. And the principal value is this amount that we actually bought the phone, the original price of the phone that we had. So that is our principal, but we are supposed to show that this principal is going to be this value here. Already the interest is there. Take note, is hire purchase, where we know that if you're dealing with hire purchase, that's a simple interest that you're going to use. So this is 7.2, where we know that amount is equivalent to P into 1 plus IN for the simple interest. All right. So the amount that we are going to have is the total amount here of 5,400 that you've got. The interest is charged per annum, which is at 7.5%. At 7.5% per annum, that is the interest. All right, so that means we are going to substitute the amount that we are given of 5,000. So let me just write it here. So we've got the amount here of 5,496. Then the interest, which was 7.5%. So 7,5, if we divide by 100, that's 0,075. All right. Then the number of years, any represent the number of years. Remember, it was covered or it was paid within 24 months. And 24 months, if you divide by 12, that is 2 years. So N is going to be 2 years. So you can substitute into the formula the amount that you are given. 5496 is equal to P into 1 plus the principal, that is the amount, the initial amount that was supposed to be paid. Then the interest of 0,075 times N, which is the number of years. All right, so you can calculate P by dividing by the bracket. So P is equal to 5496 over the given bracket of 1 plus 0,075 times 2. Okay, like that. So you can find the value of P by this formula. That's 5496 over 1 plus, we can just multiply this together, 0.075 times 2, or there's no need actually of opening these brackets. There's no need there. All right, so you're going to obtain 36 point, what did we obtain here? Oh, we forgot a comma here. All right, there is a comma there. All right, it's supposed to be the same value. Okay, so that's 4779, comma this and that and that and that. All right, so to 2 decimal place, which is comma 13. So you're going to have 4779, comma 13. So actually that is the P that we're asked to show. So that's it. This one is shown. Okay, this is the value that we're asked to show here. That's actually 2 marks. We're not supposed to have a longer working for that. On 7.3, calculate the total interest paid over a period of 24 months if the cell phone is bought on a hire purchase agreement. So if it was bought on a hire purchase agreement, we're supposed to buy the phone at this price, but we bought the phone at this price, which is a bigger price. So the interest, you simply have to subtract. So it's going to be 5,496 minus the initial amount that you're supposed to have bought this phone, which is 4,477. Okay, but don't mind my grammar. Maybe my grammar is not good. All right, I don't know. I do not know. Okay, so let's just subtract 5,496 minus 4,779. 4,779. There's a 9 there. All right, you can see that there's a 9. It's 4,779,13. All right, we are going to obtain 716,87. Okay, that's 716,87 rand. So that is the interest. It's not interest rate. The interest rate is already given here. All right, we are calculating the interest that was obtained from there. On 7.4, we are given that the cell phone is issued at, we are given that that's an insurance there at 11.5%. So if you are given an insurance of 11.5% per annum, that is per year, of the cash price, the total insurance is calculated. So which means we are supposed to have an insurance that we are supposed to add from that one. Then split up over 24 months. So we are supposed to have the insurance first. And this insurance is split over 24 months. It is then added to the monthly installment. What is the monthly installment? The monthly installment is this one, the 229 rand per month. Okay, if the customer wants to insure the cell phone. So if you want to insure the cell phone, that is what you're going to do. So the question now is calculate the new, calculate the new monthly installment. If the customer was, remember the new monthly installment was 229. So you're supposed to calculate the new monthly after we have got an insurance of 11.5% per annum from what we have. So let's calculate the insurance first. So our insurance that we are going to be charged per month, remember we are given it's 11.5% per annum. 11.5%, that's 11.5 over 100, which is 0.115. Or you can just divide on your calculator, 11.5 divided by 100, right? Divide by 100 here, that's 0.015. All right, so you have a percentage on the cash price. Remember the cash price of the cell phone, that is the normal price that we had, which is the 49 here, to the cash price of 779,13. But it's taken per annum. All right, so you're going to divide by 12. So that's your insurance there. All right, so let's see what was the insurance. 0,115 multiply by 477.913. Right, everything over 12, which is going to be 45,799. If you want to two decimal place, this one is going to change. That's 9 is going to change, and 7 is going to change into 8. So it's 45,80. Remember, you're supposed to have two decimal places. So having an insurance, this insurance now is supposed to be added to the monthly installment. The insurance is added to the monthly installment. So the new installment, that's installment. Monthly is actually the monthly installment. It is going to be the old one that we had of 229. So it was 229 Rand plus the insurance of 45,80 because it was added. All right, so if we add these two, we are going to have the new value 229 plus 45.80, which is 274.80. So you're going to have, all right, 274.80. All right, so that was the new installment. Now, after that, all right, on 7.5, the cost of the cell phone is subjected to inflation. Inflation that is going to increase, and increases to a cash price of 5,100 after 2 years. Calculate the annual inflation rate. So if you're dealing with inflation, you're dealing with the compound interest formula. So you're going to use CI formula, which is the compound interest. So on the compound interest, what you're supposed to know is that this is 7.5. The amount is equivalent to P into 1 plus the interest rate to the exponent of N, which is the accumulated amount, the principal value. So the amount is accumulated to 5,100. So that means 5,100 is equivalent to the principal value, which is the original amount of the cell phone that we had before here, which was 477. Remember that previous amount. All right, so it's going to be 477.913 into 1 plus the interest rate, which is the one that we need to calculate. Calculate the inflation rate, which is the interest rate, which is I to the exponent of N. The number of years, we are given 2 years. So it took actually 2 years to say to this value. So let's calculate I there. We can play our mathematical skills here. We can divide both sides by this expression. So that means we are going to have 5100 divide by 4779.13. All right, so if we divide, we are going to obtain 1,60. So you write all these values to the last one. That was 713. All right, to the last one. Okay, for you guys, you're supposed to write everything. 1 plus I to the exponent of 2. So what can we do to remove the square root? The square, we introduce the square root. We have given a square, so you square root both sides, you square root both sides. So by doing this, we have, you're going to actually remain with 1 plus I here. So you're going to have 1 plus I, which is equal to the square root of this number here, the square root of 1,0671, so on. All right, so I is equivalent to, we can transpose 1 to that side, which is going to be a -1. So I is going to be the square root of the answer that we had, which is this one, the square root of the answer that we had. Then we subtract 1 from that one, which is 0,033 and so on, 0,033 and so on. But this is the interest rate, which is actually a percentage. So you're going to multiply by 100% to find the interest rate, which is the inflation rate. So by 100%, we've got our inflation rate of 3,302, which is 3,30, something like that. Remember, to 2 decimal places, if you are not given the degree of accuracy, that was the instruction. So you're going to leave to 3 decimal places, which is going to be 3,30. Okay, so that was actually question number 5, question number 7.5. 7.5. So guys, please take note of these typical questions. Very, very important that you understand how to attempt these typical questions. All right, anyways, let's check the other part of the question, which is question 8. All right, On question 8, we are given a condition on probability, whereby we're given that in a random physical sciences experiment, okay, it's a physical sciences experiment, A and B are two different events. It is given that the probability of what is in A is 2 over 5, probability of what is in B complement. So take note, this is B complement is 3 over 8. Remember, B complement means not in B, not in B. Okay, then PA or B is 5 over 7. That is if you are to combine A and B go together. So the first question is to calculate the probability of what is in B. Take note, we are given what is not in B. From our laws, we know that A, so let's just use this space, the probability of what is in B plus the probability of what is not in B, which is the complement of B, gives us a 1. So that can actually be an advantage because we can just transpose probability of what is in B is equal to 1 minus the probability of what is not in B, which is B complement. So that is 1 minus B complement. That was 3 over 8. So you can subtract 3 over 8. We've got the probability of what is in B now. So that's 1 minus 3 over 8, which is simply 8 over 8 minus 3 over 8. That's 5 over 8. Or you can use your calculator there. 1 minus 3 over 8, not 5 over 8. So it's 1 minus 3 over 8, which is definitely 5 over 8. So that's the probability of what is in B. The B part is the probability of A and B. All right. Take note from the laws of probability there. We can have the probability, because we've got the probability of A or B here. Where, let's take back where this formula was taken from. So this is the B part, where we know that the probability of A or B is equivalent to the probability of what is in A plus the probability of what is in B minus the probability of A and B. So we can take advantage of this formula because we are given all the other values, the probability of A or B, which is 5 over 7. So we're going to substitute 5 over 7 in A for B. That's 5 over 7. All right. So we are going to have 5 over 7, which is equal to the probability of what is in A plus what is in B. So take note, what is in A is already given. Probability of what is in A is 2 over 5. So we are going to have 2 over 5 plus the probability of what is in B, which is the one that we calculated here, which is 5 over 8. So we are going to add 5 over 8 minus the probability of A and B. So A and B is the one that we are supposed to calculate. So you can transpose the A and B, it's a negative. So if you transpose it to the other side of the equation, it is going to be positive, which is probability of A and B is equal to 2 over 5, which was already there, plus 5 over 8. Then we subtract the minus the 7. If you transpose this to this side, it will be negative. So that will be negative 5 over 7. So this, you can use your calculator direct. Let's insert 2 over 5 plus 5 over 8. Then we subtract 5 over 7. All right, this is going to be 87 over 280. So we've got 87 over 280. Or you can actually write it as a decimal. That is, let's change, which is going to be 0.31. To 2 decimal place is going to be 0.31. So that's what you're going to have. So that was actually playing around with the question. On 8.12, we are now given, hence, determine whether event A and B are mutually exclusive. Motivate your answer. If they are mutually exclusive, then it means the probability of what is in A and in B should be equal to 0. There must be nothing actually there because it's mutually exclusive. This is there, this is there. So there is nothing on the intersection. But let's check what do we have here. A and B is equal to a certain value, which is not 0. So therefore, they are not mutually exclusive because we can see that the probability of A or B is not equal to 0. So therefore, they are not mutually exclusive. All right, so that's what you can actually give as your final answer there. Everything was direct. Okay, sorry, I forgot to check this. All right. So now on 8.2, we are given the Venn diagrams below represent different scenarios, events A and B. Write down the probability of the shaded region for each of the diagrams below. All right, so we need the probability of each. So when you see this is the shaded part, that when A and B like this is an intersection of A and B. So it's probability of A and B like this. So you can write A intersection B if you want, you can write this A intersection B. All right, here we can see that this is the part that we see in white here. This is actually A or B. So we do not need this part because the shaded part is represented the part which is not A or B. So not A or B can be written as A or B complement. That's not in A, or it's not part of A or B, or not part of A union B. It's not part of this. So it's going to be A union B complement. So that's the probability of A union B complement. And the same thing on this part here. Remember, we say this is the intersection here, but we are given the part which is not of the intersection. So it means we are given that this is not part of the intersection. So that means that will be A and B complement. So we are given A and B complement. All right. On 8.3, which diagrams in question 8.21, 8.22, 8.23 represent mutually exclusive events? Remember, on mutually exclusive events, we said we are representing a condition where A and B is actually equal to 0. We are not talking about that. It's actually equal to 0. And the only part that shows that is going to be the last one, because here there is something that is there. Here we do not have anything on the intersection. So our answer is going to be from 8.23. We do not have anything on the intersection, 8.23. All right, so that's what we had from this part. And also this part, we do not have anything that is on the intersection. So 8.22 was going to work also. All right, so that was the condition. That was the condition. And it's actually a total of 100 marks, guys. So I don't know. All you need, guys, is to work on match persons, revise as much as you can. So I think with the explanations that we have and our textbooks and also working with question papers, we can actually do the best. So let's work from as many question papers as so that's what you had, guys, from November 2018 DBE mathematics grade 10. Let's continue to revise as much as we can on Meson African motifs. Don't forget to subscribe if you're new, and also to share our videos platforms to your friends and colleagues at school so that they also can benefit from this information as we are revising towards the exams which are ahead of time. So till we meet again.